Today we're going to be talking about how to find curvature of a vector function, and in this particular problem we've been given the vector function r of t is equal to 3t times I plus 4 sine t times j plus 4 cosine of t times k. So that's our vector function. We need to find curvature. So when we're talking about curvature, we're just basically talking about how much the function curves, or the sharpness of its turns as it moves wherever it's going as t increases in the positive direction. We denote curvature with this Greek letter k, or kappa, so you'll often hear it called the curvature kappa. What we're going to do is find an equation for curvature k in terms of t. So the formula that you usually see for curvature is this value over here on the right, where we have the derivative of our vector function, r prime of t, the second derivative, we take the cross product of those two, and then the magnitude of our result. And then we divide that by the cube of the magnitude of the derivative of our vector function. So it sounds a little bit confusing, but we just have to break it down into small parts to tackle it. If you've already found the unit tangent vector for your vector function, then you can use this simpler formula here, where you take the derivative of the unit tangent vector and then find its magnitude, and then you take the derivative of your original vector function, find its magnitude. This value you already needed to calculate to find the unit tangent vector in the first place. So if you already have this unit tangent vector, then you might want to consider using this formula. But if you're starting from the beginning, then I want to show you how to use this one here. So we're just going to break this down into pieces. The first thing we're going to do is find the derivative of r of t, r prime of t. So we're going to say r prime of t is going to be equal to, and here when we take the derivative, of course we're just taking the derivative of our coefficients. So the coefficients on our I, j, and k components are these 3t, 4 sine of t, and 4 cosine of t values here. So taking the derivative, what we're going to get, the derivative of 3t is just 3, so we're going to get 3i. The derivative of 4 sine of t is just 4 cosine t, so we'll get 4 cosine of t times j. And then the derivative of 4 cosine t is negative 4 sine t, so we'll get minus 4 sine of t times k. So there's our derivative. Now we're going to need here our second derivative. So go ahead and take the second derivative. We're going to take the derivative here of this vector function we just found. Again, the coefficients only. So the derivative of 3 is just 0. So we're going to get 0 times I, and that whole term is going to drop away. The derivative of 4 cosine t is negative 4 sine t. So negative 4 sine of t times j. The derivative of negative 4 sine t, well, we're going to take the derivative of sine of t and get cosine of t. The negative 4 will stay, so we'll get minus 4 cosine of t times k. Now, as you can see, the rest is going to be magnitudes and cross products. So what we want to do is just pull the components out of each of these and then take the cross product of our derivative and our second derivative. So pulling the components out, pulling the coefficients out, here we're going to get 3, pulling that out from the I, then 4 cosine t in front of j, and then negative 4 sine t in front of k. So those are our components of the first derivative. The components of the second derivative here, we're going to get 0, because remember we have 0i, negative 4 sine t in front of the j, and then negative 4 cosine t, like this. So those are the components of the second derivative. We needed to pull those out because notice that we have to take the cross product of our first and second derivative. Remember that the cross product, and we'll just go ahead and say the cross product of our first derivative and our second derivative is going to be equal to, here we put this in a matrix and we say I, j, and k always in our first row. In our second row we're going to put the first derivative. So our components here, 3, 4 cosine of t, and negative 4 sine of t, like this in our third column. Then in our third row, we're going to put the second derivative. So 0, negative 4 sine of t, and then negative 4 cosine of t. So now we have our matrix set up, and we need to pull the cross product out of it. So remember the way that we do that, we're going to start with I here, and we're going to take everything outside of the row and column that includes I. So we're going to ignore the first row, and we're going to ignore the first column, which means we're just taking these right here, So it's basically everything outside of the row and column with I. And we're going to multiply the upper left and the lower right together. So 4 cosine t times negative 4 cosine t is going to give us a negative 16 cosine squared t. Then we're going to subtract from that the lower left times the upper right. So negative 4 sine t times negative 4 sine t is a positive 16 sine squared t. So 16 sine squared t. And even though that was positive, we always subtract this product from this product. So we have this negative sign still in front, and we multiply that by I. Then we always subtract for j. Remember, we have positive, negative, positive. So we started with a positive here in front. We're going to subtract for j. So we get minus, and then for j, we're going to look at everything outside of the row and column that j is in. So everything outside of that is these ones and these ones. So looking at those, we're going to get 3 times negative 4 cosine t is negative 12 cosine of t, minus 0 times negative 4 sine of t, which of course is just 0, and we'll multiply that by j. Then we're going to add, because we have this plus sign here, the components here for k. So when we look at k, we're looking at everything outside of the row and column that includes k, which is those 4. So we're going to get 3 times negative 4 sine t is negative 12 sine of t, minus 0 times 4 cosine t, or just 0. So we multiply that by k. So now we just need to go ahead and simplify here. We're going to get negative 16 times cosine squared t plus sine squared t. I just factored out a negative 16 because I brought the negative 16 out. We end up with a plus sine squared t times I, minus a negative 12 cosine t, so that becomes plus 12 cosine t times j, plus a negative 12 sine t, so that becomes minus 12 sine t times k. Now, because I have cosine squared t and sine squared t, that's just 1, we know from the trigonometric identity. So negative 16 times 1 just gives me a negative 16. So my result is negative 16i plus 12 cosine of t times j minus 12 sine of t times k. And if I pull the component values out of that, what I get here is negative 16, just taking the coefficients, negative 16, 12 cosine of t, and negative 12 sine of t. Now remember that these components here that we just found are for the cross product of r prime of t and r double prime of t. So we have the vector, which is the cross product of these two derivatives. Now we just need to take the magnitude of that cross product that we just found. So what we're looking at now is trying to find the entire numerator. So we've kind of been working our way inside out because we found the first derivative and the second derivative. Then we found the cross product of the two and we got this. Now we need to take the magnitude. So the magnitude of this cross product of our first derivative and our second derivative, like this, is going to be equal to, now here taking the magnitude, remember when we take the magnitude, we take the square root of the sum of the squares of these components. So we just square each one of these and add them together and put them under our square root sign. So negative 16 squared is positive 256. Then we add to that the square of 12 cosine of t, so we get plus 144 cosine squared t. Then we add to that the square of negative 12 sine t. Well, when we square this, negative 12 times a negative 12 gives us a positive 144, and then sine squared of t. And we put that all under our square root sign like this. Now when we simplify, notice here we can factor a 144 out of this 144 cosine squared t plus 144 sine squared t. So we can put parentheses around this part right here and cancel out this 144. We just factor out the 144 from this sum. And now we have cosine squared t plus sine squared t. And of course that whole value is equal to 1. So we just have 144 times 1, or 144. Which means that we're left with the square root of 256 plus 144, or the square root of 400, which we know is equal to 20. So now we have a value for our numerator of 20. We just need to find a value for our denominator. We have r prime of t, but then we need to take the magnitude of r prime of t. So we already have the derivative here, and we have its components right here. So let's go ahead and take the magnitude again. So we'll say the magnitude of r prime of t is going to be equal to the square root. Remember, we're squaring each of these. So 3 squared gives us 9. 4 cosine of t gives us 16 cosine squared t when we square it, plus negative 4 sine of t gives us a positive 16 sine squared of t. And now we have the same thing. What we do is factor out a 16, so plus 16 times cosine squared of t plus sine squared of t, just like we did in our last magnitude problem where we factored out the 144. Cosine squared t plus sine squared t is 1. So we just have 9 plus 16, or the square root of 25, which we know is 5. So this is the value of our denominator, except that we still have to cube it. So when we talk about finding curvature kappa, we get k of t is going to be equal to, our numerator we already found was 20. Our denominator is 5, but then we have to cube it, so we're going to get 5 cubed, which is going to be equal to 20 over 125. And when we simplify, we'll divide through by 5. 20 divided by 5 is 4, and 125 divided by 5 is 25. Now we can't simplify any further, so we know that curvature is 4 over 25. That's our final answer, and that's how you find the curvature of a vector function.